Have you ever opened a scientific paper and just felt completely lost? Like you've hit a wall of dense technical jargon? Well, it can definitely feel impenetrable. But here's the thing. There's a key to unlock it, a kind of secret code, and we're about to crack it together. Let's dive in.
Yeah, this looks complicated, right? That's because it is a code. But here's the good news. Almost every single scientific paper is built on the exact same blueprint. And once you see that blueprint, you'll be able to read pretty much any paper in any field and pull out its core message, I promise.
So first things first, we've got to understand the why. Why do scientists even go through this incredibly painstaking process? It's not just about listing off a bunch of facts. It's much bigger than that. And this, right here, is the most crucial point. You have to think of science not as a big, dusty book of facts, but as a massive, global conversation that's been going on for centuries. Every single paper is like a new person joining that conversation, listening to what's already been said, and then adding their own unique piece to the puzzle.
You see, publishing is about so much more than just getting your results out there. It's about creating a permanent record, stamping your work into history. It's about getting credit, finding other people who are interested in the same stuff, and, this one's a biggie, surviving expert feedback through something called peer review. That whole process is what validates the findings and officially locks them into the scientific record. It's literally how we build knowledge, piece by piece.
So, you want to join this huge conversation. How do you structure what you have to say? Well, this is where that secret blueprint I mentioned comes in. It's a storytelling structure that's actually really elegant, and, when you think about it, makes perfect sense.
It's an acronym called IMRAD. That's IMRAD. Introduction, Methods, Results, and Discussion. And the best way to visualize it is as an hourglass. Honestly, this hourglass shape is probably the single most important key to unlocking how any scientific paper flows. Let's break down what that means.
Okay, so the top of the hourglass, the wide part, that's the introduction. It always starts out broad. It's designed to hook you with a big, important problem. Why should anyone in the world care about this research? It covers what other people in the conversation have already discovered, and then it slowly narrows down to point out one specific, unanswered question, a gap in our knowledge. Next up, the hourglass narrows to the methods section. Here, the focus gets laser sharp. This part is all about credibility. It tells you the exact steps the scientist took, the materials, the procedures, the statistics, everything. The goal is that another scientist could read this section and do the exact same experiment. This is the solid foundation the whole paper is built on.
And that brings us to the narrowest point of the entire hourglass, the results. This is the absolute heart of the paper. There's no interpretation here, no wild speculation, it's just the facts, ma'am. This section presents the key data from this one study, usually in graphs and tables. This is the brand new piece of evidence being added to the big conversation.
And finally, we have the discussion. See how the hourglass widens back out? This is where the author steps back and says, okay, so what does all this data actually mean? How do these results fill that gap we talked about in the introduction? How does it change our understanding of the big picture? It connects this one specific finding all the way back to that global conversation, bringing the story full circle.
All right, now let's zoom in on that critical results section. Because the best scientists aren't just great at collecting data, they're master storytellers who can make that data speak loud and clear.
Take a look at this chart. Sure, it's full of data, but it's also packed with what designers call chart junk. The symbols are too similar, there's a lot of visual noise from those error bars. The main point is totally lost. The story is in there somewhere, but you, the reader, have to fight to find it. A great paper will never, ever make you do that.
Okay, now look at this. It's the exact same data, but presented way more effectively. All the clutter's gone, the symbols are clear and distinct, which makes the main comparison just pop right off the screen. The story is now instantly, intuitively obvious. It's the same data, but one is a confusing mumble and the other is a crystal clear statement.
Let's try this again, but with a table. So here we have data from 8 different soil samples. All the numbers are there, but the rows are just listed in the order the scientist happened to collect them. Go ahead, try to spot a trend. It's pretty much impossible, right? Your eyes just kind of glaze over this sea of random numbers.
And now for the magic trick. Watch what happens when we do just one super simple thing. We sort the rows based on one of the columns from lowest to highest, and bam!
all of a sudden a story jumps out at you. As the clay content in that first column goes up, every single other measurement goes up right along with it. That relationship is now completely unmissable. That, right there, is the art of turning raw data into real knowledge. So, an author has built their case, they've crafted their story, and they're ready to join the scientific conversation. But before they can get in, they have to get past the gatekeepers. This is the absolutely critical process of peer review. What happens is, the journal editor takes the paper and sends it out to 2 or 3 other experts in the exact same field, and they do it anonymously. These reviewers act as a quality control filter for the entire scientific community. Their job is to be brutally honest and pick apart every aspect of the paper to make sure the science is solid.
And they come at it with a checklist of really tough questions. Is this work actually new? Is it a significant step forward or just a tiny one? Are the methods scientifically sound? And here's the most important question of all. Do the conclusions they're making actually follow from the data they presented? A paper has to get a solid yes on all of these to make it through the gates and join the conversation.
Okay, so now you understand the purpose, you've got the hourglass structure, and you know about the quality control, you basically have the decoder ring. So let's put it all together into a simple, practical plan for how to tackle any paper you come across.
Now, the number one key is this. Do not read a scientific paper from front to back like a novel. That's the biggest mistake. Instead, you do it in 3 steps. First, just read the title and the abstract. That's like the movie trailer. It gives you the entire story in about 250 words. Second, skim the introduction to find the main question, then jump immediately to the discussion to find the main answer. This gives you all the context you need. And only then, for step 3, do you go to the results, the figures and tables, to see the actual proof for yourself.
So if there is one thing to take away from all this, it's that a scientific paper isn't just a dry report of facts. It's a persuasive argument. It's built on a very specific logical structure, it's supported by carefully presented evidence, and it's been vetted by other experts. In other words, it's a story, and now you know how to read it.
By seeing past that complicated surface to the elegant structure underneath, you're no longer just a passive reader. You become a critical participant. You can evaluate the evidence for yourself and understand how our collective knowledge of the world moves forward, one paper at a time. So the only question left is, what conversation are you going to join?